And welcome in, my party people, to Circle Word Problems. Let's go ahead and have ourselves a good class here because today, mostly, just like geometry questions, today circles, it's part of the same group in the sense of, and this is something I always say about geometry, is that there's always a formula, there's always a definition, there's always something you can rely on. And so with that said, that's no different today. We're going to be learning four main terms that have relationships and formulas. And those four main terms are pretty familiar. You might have heard of them: radius, diameter, circumference, and area. So let me go ahead and highlight all of this because that's the first thing we're going to do. We're going to understand the radius, diameter, circumference, and area one by one. And then once we have a good understanding of what that looks like on paper, on an actual circle, we're going to elevate that understanding after some examples into word problems where they're not going to tell you what the radius is or what the diameter is or what the circumference is or the area is. What they're actually going to do is say things like, hey, across the pond instead of saying diameter, or all the way around the pond instead of saying circumference, or hey, from the center to the edge instead of saying radius. And I know some of us here who are either watching live or as a recording, you might have seen some of those phrases in word problems, and maybe that's starting to open some eyes, but we're really going to build that confidence in today's class. Because once we have those definitions set, it's all about those word problems. I know that's what we're here for today, so let's get to it. So first things first, everybody, we're going to go through 4 pages of notes, starting here with the radius of a circle. And what I'm going to do first is I'm going to go ahead and illustrate this for us. We'll take our notes, and then we'll move forward to pages 2, 3, and 4. After that, we're going to get straight into the examples, into the word problems, and then continue the time practice from there. So first things first, everybody, let's define a radius. Let me go ahead and highlight that. So the radius, basically it's like this. If we were to go ahead and draw a nice little circle, let's go ahead and use blue. So there's our blue little circle. So if we were to draw a little segment from the center to any point on the circle, any point being literally any point on the circle, if we draw a segment from the center to any point here, that is called the radius. All right, that's the radius. This is just something that we're going to have to wrap our heads around. This is the first term of the day. So again, the radius is the distance from the center to any point along the edge. So with that, go ahead, take a moment, copy that down. We're going to move forward in a bit over to diameter, circumference, and area. All right, so let's go ahead and move the conversation forward, like I said, and let's talk about the diameter. So if we were to just take a moment here and go back to our notes on radius and just grab this and copy this over to the next page, the diameter is not the halfway point. It's not from the center to any point along the edge. No. The diameter is going to be an extension. Yeah, the full distance. So let's go ahead and actually erase the phrase radius. And let's go ahead and use purple and draw the line all the way across. And again, that is going to be the diameter. The diameter is the distance across the circle. The key word here, let me just go ahead and highlight diameter. But it's the distance across a circle through the center. So if we want to write the relationship down, the direct mathematical, kind of algebraic relationship, this is how we're going to want to think about it. The diameter is, again, the full distance. It is going to be double the radius. And if you want some proof of that, no worries. Let me go ahead and just zoom in real quick because we can go ahead and say from here to here, that is a radius. And then from here to here, that's also a radius. Because remember, everybody, just in case anybody's confused on this, remember that the radius is from the center to the edge. The center to the edge. So you have 1, 2 radii there. So with 2 radii being there, or 2 radiuses, if you want to pronounce it fancy, you have the diameter. 2 of the radii all the way across is the diameter. My party people, yes or no, does that make sense? Before we continue. Right on. And another way we can write this before we move forward is the radius is going to be the diameter cut in half. Diameter divided by 2. So again, the diameter is double the radius is half of the diameter. And you guys know that when I repeat myself 10, 15, 20 times, you know it's going to be a big part of today's class. So let's get ready for some laughs. So with that, go ahead, finish taking your notes, and we'll move forward momentarily. All right, so let's go ahead and continue the conversation here. We're going to move it to the third page and talk about the circumference of a circle. Now, let's read the definition really quick, and I'm going to ask y'all what this reminds you of. So the definition here, the circumference, before I draw a picture, before I do anything like that, the circumference is the total distance around a circle. And we calculate it using either one of these formulas. To make life easy, I'll go ahead and highlight one of them as green and the other one as purple. Again, both of these formulas are going to be the same exact thing. But my question still stands. When we talk about circumference being the total distance around a circle, can anybody tell me what that reminds you of? You know, total distance around any shape? Yeah, absolutely. That's going to be perimeter. All day, every day. When we think about perimeter for a square, triangle, a rectangle, it doesn't matter. The perimeter is the distance around that shape. The only reason, my party people, the only reason that circles have a different name for the distance around a circle is simply because of this. When we think about squares, circles, rectangles, not all of them have sides. When we think about a circle, we don't have any sides. There are no flat sides on a circle. It's not even infinite sides. It's just an infinite set of points that define a circular shape. So when we think about the definition for a perimeter, adding up all the sides, it's just because of a little technicality. There are no sides on a circle, so you couldn't really call it perimeter. So if we want to still calculate the distance, we got to call it something else. And that's where the name circumference came from. It goes all the way around. My party people, does that make sense before we continue to talking about the formulas and where those come from? Perfect, perfect, perfect. Right on. So everybody, let's go ahead and really understand why these two formulas are the same. So the reason that these formulas are the same is, well, let's actually work on it together. Let's talk about this. Everybody, D stands for diameter. Over here, R stands for radius. Can anybody tell me really quick the diameter versus the radius? You know, if I wanted to take the diameter, what do I need to do to the radius to get to the diameter to make it the same? How do I write that? How would I think about that? The diameter is what? What's the diameter relative to the radius? Giovanni over here says double, and yeah, absolutely correct. Let's go ahead and see. Everybody, do you agree if I were to say that the diameter is the same thing as double the radius? Would you all agree with me if I said that? Yeah, we wrote that down a couple of pages ago, right? Yeah, the diameter is absolutely double the radius. Now there's something I want to show you. I'm going to go ahead and let's go ahead and use red to be consistent here, to not mess up any of the highlighting. But take a look at the diameter right over here, right? There's our diameter. And then let's take a look at the 2 and the R right there. Again, the diameter equals double the radius. One more time. Diameter equals double the radius. What would happen if I just replaced the 2 and the R with the diameter? Oh, look at that. It's the same exact formula. They're both just pi. For one of them, we'll go ahead and write diameter. But if we didn't want to use the diameter, for example, everybody, let's say we have a word problem that we're dealing with, and they say, hey, find the circumference, calculate the circumference. But they give you the radius instead of the diameter. Well, guess what? We can just replace the diameter with double the radius. This is all multiplication. So you could say pi times 2 times r, but typically we like to write the whole numbers in the front. So that would just be 2 pi r. The 2r and the d, they're the same exact thing. So technically, we can have two formulas, but they quite literally are the same thing. It just depends on if you're given the radius, use this one, or given the diameter, using that one. Now, party people, hopefully that it's not confusing, and hopefully I've given you a little bit of insight into this, but does that make sense personally for you? These are the same formulas. Only difference is that one uses the radius, the other uses the diameter. Perfect. So we'll go ahead and zoom on out and finish this quick little overview. So let's just talk about this symbol right here. This is called pi. P-I, not P-I-E. I know it's Monday and we're hungry, but this is P-I, pi. Pi, when they tell you to approximate it, when they tell you to calculate with the approximation, typically they will say use 3.14 for pi. Here's the, just a big grand thing. The one thing you want to make sure you remember is you want to leave it as pi unless you're told to use 3.14. One more time, everybody. Leave it as pi unless you're told to use 3.14. Because sometimes, again, when I keep referring to that word problem anxiety, where some people will just grab numbers and calculate with them and then do what they think is right and then check the problem, we got to make sure we read the whole problem, especially if we're dealing with circles, to know if we use pi, 3.14, or the occasional 22/7. So with that said, everybody, let's go ahead, take these notes down if you haven't had a chance to finish it off, and we'll move forward here momentarily again. All right, and getting over to our last page of notes where we're going to talk about the area. So we're going to have, what we see on the screen, obviously. I'll have a quick drawing in a moment. And then I'm going to give you one more thing to really help you know the difference between, hey, how do I know when I have to calculate circumference versus how do I know when I have to calculate area if they don't actually give me those words? I got you. So really quick, the area is basically just going to be the amount of space inside of a circle. Here's the formula. Area equals pi r squared. Pop quiz, everybody. Let me zoom on in right there. R squared, what does that mean, everybody? What am I supposed to do with r if I know what it is? Let's say I have r equals 8. What do I do with r squared if r is 8? What does squaring a number mean? Yep, that means multiply that number by itself. So if it was r squared and r is 8, that's 8 times 8. If you don't have anything for r, well, that's the same thing as saying r times r. Remember, knowing your operations is a very valuable thing to know, especially on a test like this. So let's go ahead and have our little drawing come out here real quick. And then I'm going to give you a nice little tip to take with you throughout the rest of class. So here's our circle again. And when we talk about area, again, we're talking about the space inside. So let me just highlight this and then just remind us again. Area is the space inside. So with that said, let me just put a little arrow there. That is the area. And here's the tip of the day. Everybody, just like I said, word problems are not always going to give you explicitly the word circumference or explicitly the word area. Sometimes you have to use context clues. So let me go ahead and give you some context clues for area. For area, whenever it's given to you or asked of you, they will likely say square units. And some examples of that would be, we can do centimeters squared, we can say feet squared, we can say square inches, we can say square miles. Those are all examples of square units, each and every one of these. Again, when the units are squared, we're not talking about regular straight line distance. We're talking about square distance. When we are talking about circumference or perimeter, if you understand it better that way, we're talking about, again, a distance. That is what circumference is. It is a regular distance. It can be centimeters, inches, miles, yards. But if we're talking about area, it's always going to be presented in square units. My party people, even if we don't understand that 100% because we don't have the experience, do we at least have this written down before we get started on example number 1? All right, let's get into example number 1 here. Let's just take in what we see. Everybody, first things first, can you tell me, give me the one word that we're trying to find? Give me the one word we're trying to find. And I want to use this as practice of staying focused on the goal first, on that destination. It's going to be right here. It says, find its diameter. We are looking for the diameter. Remember, the first thing we want to do in simple or complex word problems, it doesn't matter. First thing we want to do is understand the goal. What's the question? Find the diameter. Sounds good. Let's go ahead and draw a little circle here. And here's what it says. It says that we're dealing with a circle that has a radius of 8. So if I were to draw the radius, remember that's going to be from the center to the edge. And so the radius equals 8. Everybody, pop quiz. What do I do to the radius to get to the diameter? What do I do to the radius to get the diameter? Yes, we double it. Remember, the radius is the halfway point. The diameter is all the way through. If you're halfway, you got to multiply by 2 to get the rest of the way. So that's going to be, again, right here, all the way through. That's going to be diameter equals 16. Again, a diameter equals double the radius. So we would multiply 8 by 2, and that's going to give us 16. And there we go. So with that said, are we good to proceed to the next example? I think this one was pretty straightforward, right? Sounds good. So again, with this one, just looking for the diameter, we have the radius. We had to think about the relationship between the diameter and the radius. Starting from the radius, multiply it by 2, and there we go. Let's go ahead and get into this one. Everybody, what are we looking for here? Give it to me, 5 seconds. Go ahead, one word. What is it that we are looking for? Yeah, we're looking for the radius now. Find its radius. So we are looking for this right here. I don't know what this is yet, but what we are told is that the diameter of the circle is 12. So with that said, okay, I'm told that we have all the way from here, all the way through. And everybody, if we're starting from the diameter, how do we get the radius? Yeah, that's right. Who said it? Let me go ahead and just put up there. Yeah, Floor, that's correct. We're going to divide it by 2. So we'll take that diameter, which is going to be 12. We will divide that by 2, and that's going to give us 6. I know these problems seem very straightforward, very rudimentary. I will agree with that in terms of the numbers, but I want to get your mind acclimated to dealing with the terms. So that's what really this is about. If we want to get to the diameter from the radius, we double it. We're trying to get to the radius from the diameter, cut it in half. That's the big key here. Now let's take a look at this third example. This third one here, we have the radius of a circle being 4. What we're looking for though, instantly what we should pay attention to is that we're looking for the circumference. Now my party people, one more time though, because this is something that we kind of touched on but haven't really emphasized. Everybody, when I calculate whatever it is I'm calculating, am I going to use pi or am I going to throw in 3.14? Or do I not know yet? Yeah, the problem is stating it right there for you. Right here in this parentheses, it says use pi as pi. So just leave it as is. Nothing needed there. We're all good. So let me just highlight that in green in case we need to come back to that at the end. But let's understand this. Everybody, we are trying to find right over here, find its circumference. Everybody, if I'm grabbing my notebook over here, pretending to be a student, okay, let's go ahead and see. All right, there's my formula. Let's write that down. Oh, wait, what the heck? I have 2 formulas. I have one being something like this, and then the other is something like this. Now, that's a problem. Has anybody here ever been in a situation where you might have had these 2 formulas and wondered, I don't know which one to use. I don't know which one I'm supposed to use here. Yeah, very common feeling. This is a very common feeling, but it has a very simple approach. Here's how we're going to do this. Everybody, we know our destination. We know we're looking for circumference, so we can feel pretty good about that. Now, when we take a look at the information that we're given, we see that we're given the radius. The radius of a circle is 4. So if I write that down on the side, again, radius equals 4. I'll just use the full word as well. Everybody, tell me, which of these formulas specifically states radius in it? The first one, that is correct. 2 pi r. When it comes to circles, the letter r stands for radius. So r stands for radius. Everybody, one more time, help me out. What does the d stand for here? What does d stand for in that circumference formula? Yep, that is diameter. That's correct. We have diameter right there. So because of that, everybody, because of that, logically speaking, if we're just thinking about it as, hey, we got to find circumference. There's 2 formulas. We have the radius. Now we know which formula we're going to use, right? I think it goes without even asking. I think it's clear now that because we have the radius and this formula is the one that uses the radius, this is the formula that I want to use. That's the one. Do you agree or disagree with me here? Right on. So here's all we have to do. Number one, we're going to swap out r. We're going to swap out the radius with what it actually is. The 4 right over here. We're going to swap that in. And then when it comes to pi, everybody, remind me. Are we leaving it as is, or are we supposed to replace it with 3.14? As is. That is correct. As is. Notice it right here again. Got to stay focused under pressure. It says use pi as pi. Remember, with these geometry problems, there's a lot of guidance. So with that, we are going to leave pi as pi. So 2 times pi, and then the radius I'm going to plug in as 4 right over here. And there we are. Now, when we go ahead and solve this, we're not quite done because we can bring together the 2 and the 4 through that multiplication. 2 times 4, everybody. That's going to be what? Yep, nice and easy. That'll be 8. We leave the pi as is. Again, that's what that means. Leave pi as pi just means leave pi as pi. Our answer is 8 pi. And there we go. So our circumference is going to be 8 pi units. Whatever the units are in actual word problems, it could be feet, could be centimeters, could be miles. That's what it is. 8 pi units, we leave it as is. One more time, if you're asking where that 4 randomly came from, remember that it replaced the radius. What was the radius? The radius was 4, right there. So there's our first, this is our first almost word problem, right? We have to go ahead and interpret the information, interpret what we have, but there's no context, there's no story. We're going to get to that in a few. So just remember, we just calculated the circumference, which is going to be the distance around the circle. So all the way around, kind of like perimeter, that's what we just calculated in this one. Coming up next, let's take a look at, look at this. We want to do the same exact thing. We want to find this shape's circumference. Okay. We want to find the shape's circumference. And we're going to do the same thing that we did in the previous question. Circumference, everybody, that's a pretty specific geometric word, right? That's a very specific term. There's a specific formula for it. In fact, there's 2. And that's going to be circumference equals 2 pi r. And then the other formula we have is circumference equals pi times d. My party people, in this situation, in this circumstance, given that we are told that the diameter of this circle is 14, which of these formulas should I select? Number 1 or number 2? Yeah, the second one. Exactly. We'll select the second one because, again, we have the diameter. Let me actually use blue to be consistent. We have the diameter. The diameter that we're given equals 14. So again, everybody, when it comes to the circumference formula, it really depends on if you have or are trying to find the radius or diameter. That'll guide you into picking the right formula. So over here, we'll plug it right in and you'll see that you're done. Because it says, again, use pi as pi. So pi stays the same. Nothing happens there. Our final answer is circumference equals pi times 14. Again, plugging in that diameter right there. And typically, proper math is just going to be 14 pi instead of pi times 14. It's shorter, saves you time, and there we go. So my party people, after these 2 questions, between this one and the previous one, where we use the radius for the circumference formula and the diameter for the circumference formula, are we feeling pretty good about this? Good. Right on. And one thing that I want you to think about as we move forward one step at a time here is as we get into those stories, the context, the word problems, you want to ask yourself, how do I know which formula I'm using? What do I have or what has the problem said that makes me believe that I should use this formula? So obviously, the formula could be the diameter, it could be the radius, could be circumference, could be area, but you always want to ask yourself, hey, if this is what I think I'm supposed to do, can I convince myself? How do I know that I'm right? Here we go with the next one. Let's take a look at this problem where it says, hey, Mr. Lee is jogging around a circular track. My party people, quick question. Is that the first thing I'm supposed to do? No, right? It's not. We want to read the question first. We want to read the question sentence first. Everybody, when we read the question sentence, again, there's our question mark, there's our directions. Let's take it nice and slow here. Regardless of how confident or confused you are, always read the question first. Here we go. To complete one full lap along the edge, what is the total distance he covers? Everybody? I don't see any specific verbiage here saying circumference or area or trying to find radius, but we can interpret it. Everybody, if we understand that, yes, of course, this is a circle class, so we will go ahead and draw a little circle over here. But if we just interpret what is being said, to complete one full lap along the edge, one full lap along the edge. What does that sound like to you, everybody? Does that sound like perimeter or area? Or in this case, circumference or area? Yeah, circumference all day. That's circumference all day. And all we want is just one full lap. So one full lap, total distance, that is circumference. That is what we want. Before I even continue, even for those of us that are confused, can we start associating confidently that going around a shape, going fully around a shape, that is the perimeter or circumference of that shape? Is that starting to set in for you personally? Remember, we can associate circumference with perimeter in the sense that the circumference is just the perimeter of a circle. The circumference is the perimeter of a circle. That's it. So now that we're here, you might be thinking, well, okay, circumference is a very specific geometric term. I got a formula for that. Yeah, we do. We have two. So let's not get ahead of ourselves. Let's understand what information we're given so we can see which formula we might actually use. Mr. Lee is jogging around a circular track. Okay. The track has a diameter of 50 meters. Diameter, that's a very specific word I want to highlight, and it says 50 meters. So everybody, when I draw diameter, since I never make a mistake, this is the right way to do it, right? Diameter right there, 50 meters, right? Yes? Yeah, no. That's wrong. That's absolutely wrong. What did I actually just draw, everybody? What did I actually accidentally draw? Yeah, that's the radius. I accidentally wrote the radius. Let me go ahead and take that out. If I want to write the diameter of 50 meters, that's going to be from one edge over here all the way through the center to the other side. That right there, everybody, that is the diameter going all the way through of 50 meters. So there we are. Now, with that said, we have the diameter. There's a specific formula for the diameter, and that is going to be right over here, pi times the diameter. So all we have to do now is plug in the number that we have for diameter. But everybody, are we done after that? Because we have pi times 50. Is that it? Are we done? Nothing else to do? The answer is 50 pi? Or is there a specific detail that we might want to adhere to? Yeah, there's one more detail, right? What's that detail going to be? Someone already called it out. Yeah, pi is 3.14. Right over here. Let me highlight this. Pi is 3.14. So I hope we understand that I'm not here trying to trick anybody. I'm not here trying to aggravate anybody. What I hope you notice is that the details are right here in front of you. These details that are important are right here in front of you. We really just have to practice taking the time that we need to getting this information. Again, don't rush and calculate instantly. Take a second, understand your question, understand your information, make a plan, and calculate. Does that help anybody out? Does that make sense to anybody here? Perfect. Again, destination, plan, follow all day. So the pi will be replaced. Let me highlight this in green. The pi will be replaced with 3.14. The 50 stays a 50. And now what we're going to do is calculate 3.14 times 50. So I'm going to zoom in for a moment and I'll zoom out momentarily. Don't worry, you'll still be able to get to take your picture of your notes before we move forward. But here we go. 3.14 multiplied by 50. And so here's what we're going to do. To multiply by a decimal, in case anybody here is nervous about that, what we're going to do is we're just going to ignore the decimal, and we are going to multiply. Multiply normally. It's at the end that will bring the decimals back. Again, at the end, we will bring the decimals back. So here we go. First up, 4 times 0, well, that's going to be 0. 1 times 0, well, that's going to be 0 again. Look at that. That's pretty easy. Then we have 3 times 0, and that's going to be 0. Look at that. Next up, we want to start off where the 5 is. So we need to put a 0 right here. So we'll move that out of the way, and let's get to work. 4 times 5, that's going to be 20. And we'll carry that 2. Then we have 1 times 5, that's going to be 5. Carry the 2, that's 7. And then from there, we have 3 times 5, and that's going to be 15. So with that said, everybody, we're good. We're going to add all this together, and we're going to get 0, 0, 7, 5, and 1. So that's step 1. We have ignored the decimal and have completed multiplying. And then step 2, we're going to bring the decimals back. We have 1, 2 decimal places, nothing over here. So just 2 decimal places that we'll bring back here, 1, 2. So the answer is going to be 157.0, or just 157. Y'all tell me, is it going to be meters or meters squared? Which one is it going to be for circumference? Yeah, it's just going to be meters because, again, everybody, we're dealing with a distance. The distance around the circle, and that's just regular units. That's just meters. That's correct, Anisha. Square meters would be area. Exactly. So with that said, everybody, booyah, let's go ahead and zoom it on out. Here you go. The correct answer here will be A, approximately 157 meters. And there's our first problem. There's our first word problem where we actually had to figure out, again, we weren't fed with a silver spoon. We actually had to figure out, hey, we're looking for circumference, and hey, we're going to use this specific formula. Who here feels like it's possible for them now to eventually try some on your own and actually know what formula you're supposed to be using? Sweet. Again, everybody, it's about getting one day better, one day at a time, one problem at a time. That's all we got to focus on. So with that said, let's focus on the next problem. So here's what we're going to do. I'm going to pull up the next problem, and I want y'all to instantly point to or type into the chat box, or if you're watching this as a recording, just yell it out loud. Go ahead and identify what the goal of the problem is. I don't care about what else is on the screen. It could be a picture of my face making the funniest face in the world. I don't care what's on this next screen. Identify the question first. 3, 2, 1, hit me. What is the goal of this question? Give me one word for it. I want one word. Yeah, you could definitely take a peek here and say, one word, but I'm reading distance around the edge of the fountain. Well, yeah, when you think about the distance around the edge of anything, yeah, that is, in this case, given that we see a circle, that is circumference. Distance around the edge of the fountain, that is circumference. That's what we want. So as soon as we know what we want, the big advantage that we have is we know that there's a formula for this term. We just have to realize or figure out, hey, are we supposed to use option 1, which is 2 pi r, or are we supposed to use option 2, which is pi times d? That's all we have to ask ourselves. And to understand this, the letters give it away. The letters say, hey, we have r for radius, d for diameter. A circular fountain has look at that. It's almost like they have to be specific because these are very specific terms. Radius of 10 meters. So given that we are given the radius, we are going to use the formula that uses the radius right over here. This is the radius version, and here is the diameter version. The big winner right here is the first one. So now that we know which is the right formula to use, given the information we have, we can make a good decision. We can plug in the value into this formula. And if you take a look at the answer choices, everybody, if you take a look at the answer choices, are we going to be replacing pi with 3.14, or are we going to leave it as is? Yeah, we're going to leave it as is, because notice pi is just pi in the answer choices, so we'll leave pi as pi in our calculation. Again, we can answer those questions that we have, those bits of roadblocks and anxiety. We can ask questions to move past those moments. So here we go. Let's plug in what we have. Circumference equals 2 times leave pi as pi, and the radius was 10. We plugged in the radius as the right value, and now we can clean things up and just say 2 multiplied by 10, my party people, that's going to give us 20. And so we have 20 pi, and that's it. We're all done. The big bad diameter problem, it's really not that crazy at all. And so we can highlight the correct answer as B, 20 pi, and we're all set. My party people, so far, how are we feeling? Do we feel like we might be, getting to the point where we might be ready to start trying some word problems on our own? Cool, sounds good, sounds good, sounds good. So let's go ahead, and before we even get into the next problem, I just want to take a quick little detour. And that detour is just going to be this. My party people, if we had a formula, let me just zoom on in over here. If we had a formula that said, well, let's use this one. Let's say we had a formula that said, hey, circumference. Everybody, to get the circumference, what operation did we use? Help me out. To figure out what the circumference was, what operation did we use? Yeah, we multiplied all the way through. 2 times pi times 10. So to get the circumference, we multiplied to get it. Everybody, if it just so happens that we try a problem where we have to work backwards, we are given the circumference and we have to find the radius, let's say, what operation do you think we might need to utilize to work backwards? Yeah, division. That's division. So that's all I wanted to go ahead and kind of, just remind y'all of before we get into this next problem. So everybody, here we go. Go ahead, point out the goal of the question. Yeah, that big word that we might want to, really pay attention to is going to be distance. Absolutely. But then when we put it all together, what is the distance around the edge of the plaza? That makes us think what again? When it comes to circles, yeah, circumference all day. Circumference all day. So once we understand that, what we're going to do now is we're going to say, well, there's 2 formulas I can use. We can say that we have 2 pi r, or we can use pi times d. So let's read here. Oh man, in this problem, I'm looking at this and I'm thinking, I don't see the word radius or diameter given to me. I don't see the explicit word being thrown my way. This is a moment where, again, very common for a lot of folks to feel a little closed off, a little anxious about not having it really given to you. But stay calm, cool, and collected. Read through one sentence at a time. A circular plaza is designed such that a straight path goes directly across its center. Again, straight path goes directly across its center. Let me go ahead and draw a little circle. And let's say it has a straight path that goes directly across the center. Everybody, by definition, what is that called? If you go from one edge of the circle to the other, going through the center, yeah, that's diameter all day long. So now that we know we are given the diameter and it measures 30 meters, we can be pretty happy. We have diameter equals 30, again, going all the way through. And we can say with confidence that we should use this formula here. Why again? Because again, it uses the diameter. This one uses radius. This is the right one. They're both the same formula. But let's use this one. Circumference equals pi times 30, and that's just going to be 30 pi. And that's it. This is just an exercise in knowing how to plug things into the right places, but you can't plug things into the right places unless you can confirm that you're using the right formula. So again, little bit at a time, one step at a time, and this can feel easy step by step. Answer choice here is B, 30 pi. So with that said, everybody, how are we feeling so far? Right on. I'm glad we're feeling good. I'm glad we're feeling good. So, with that, let's move it over here. And I want you to try the next one out because at this point, everybody, we should have our formulas. We should have our definitions for a radius, for diameter, for circumference, for area. And now it's not just about knowing the formulas, it's about knowing how to point out those pieces. Can you read the description of radius and identify it as radius? Can you read the description of diameter or circumference or area and identify it as such? So with that said, everybody, let's go ahead and try the next one out. Let's try it on our own. Let's see what we got. All right, so let's get into this problem about circles. So my party people, first thing we always do is we're going to read that question. And luckily in this one, it's not terribly complicated for the goal. We see that it says, using this information, what is the area enclosed by the park? So everybody, when you think about the word area, the one thing that I've really taught us folks here to think about instantly after that is what shape. If we see area, that's a very specific geometric word. So we got to ask ourselves, what's the shape? Because if it's a square, that's side squared. If it's a rectangle, length times width. If it's a circle, pi r squared. So given that we're talking about the area enclosed by the park, it says that it's a circular park. So we're dealing with the area of a circle. Area of a circle, that is going to be area equals pi r squared. And then pop quiz, everybody. Pop quiz. What does the R stand for? Help me out. You know me. I'm very forgetful. Radius. Okay, let me just make sure that is highlighted. Let me just go ahead and boom, that is radius. All right. So, once upon a time, Coach Anderson said that quite a few people, suffer from a little bit of math anxiety and test anxiety. And one of the symptoms might be grabbing numbers and just throwing them in. The first inkling you get that you have a correct answer, you're going to take that number and just toss it in and calculate with it, not caring or hoping that you get the question right. Let's see what happens if we were to do that. So we have a circular park as a straight path stretching directly across its center that measures 18 meters. Some folks will think immediately, hey, 18 meters, let me plug that in. And what that will cause some of us to do is, and I'm going to just make sure to write that this is wrong before I even write what I'm going to write. Most folks will say, okay, cool, area equals pi times 18 squared, plugging in the 18 for the radius. But my party people, quick question. It says a straight path stretching directly across its center. That's what measures 18 meters. Everybody, when I draw it out for us, easy to see. When we take a look at going across the center, let me go from the top left to bottom right. Again, just making sure that you see that it can happen any which way. If I go all the way across, everybody, what does that 18 represent? What does that actually represent? Yeah, that's diameter. That is the diameter. Again, going across its center, the diameter equals 18 meters. So with that, give me a yes or no, very briefly. Who here understands what their mistake was? Who here understands the mistake that they may have made? Good. This is how learning happens. Again, one bit at a time. So even if we're, frustrated and saying, dang it, hey, that means you care, and I'm not going to fault you for that. But let's take this little bit of knowledge and let's lower the probability of making the mistake again. That's all it is. Bit by bit, proper practice. So with that, we are not plugging in the 18. That is going to be wrong because this is not the radius. So what we need to do is we got to ask ourselves, hey, look, I don't have what I need. I need to get to the radius, but I have the diameter. Everybody help me out. If I have the diameter, how do I get to the radius? Yeah, we divide specifically by 2. Exactly. This is what you want to say out loud or in your head. This is how you want to guide yourself through that conversation. So I don't have the radius, but I can get there I can do that by cutting the 18 in half. So 18 divided by 2, that's going to be 9 meters. My radius equals 9 meters. Now that I know what the radius is, now I can plug it into the right place. Let me get this out of the way. Now I'm good to go. Area equals pi multiplied by the radius, which is 9 meters, squared. And everybody remind me again, squaring a number, so squaring 9 squared, don't give me the answer, give me the operation. That's 9, 9 times 9. 9 times 9, that's going to be 81. Again, that is 9 squared. So what we have here is pi multiplied by 81, or 81 pi. And there's our answer. Boom. It is actually not going to be A. It's going to be answer choice C. And just a quick pop quiz before we continue. This is going to be very important. Given that the units that we're using are meters, what are the units for our final answer? 81 pi what? It's going to be 81 pi, correct, square meters, or meters squared. Just like that. Again, because it is area. Because it is area, it's always a square unit. And there we go. So my party people, again, this is a question that anybody could make that mistake on. Anybody could take the first number that they see and just plug it in. But it just takes, again, a little bit of patience. Just that essential fundamental strategy. What do I want? What do I have? What's the connection? Or in other words, what's my destination? What's my plan to get there? All right, let's follow that plan. Who's here? Who here is ready for another one? All right, here's our next one. The question clearly reads, again, ignore everything else. Straight for the question sentence, we see that it says, hey, what is the area? What is the area of this shape? What is its area? Sounds good. Boom. Now, as always, area is a hyper-specific geometry word. So what we're going to do is look for the shape that we're dealing with, and it says a circle. So because of that, we are going to move forward and say that we're looking for the area of a circle, which is pi multiplied by the radius squared. One more time, everybody. What does the R stand for? One more time. Yes, the R stands for radius. So what we are going to plug in is the radius. Everybody, is that what we're given, or do we have to do a little bit more work to find the radius in this problem? Yeah, we're given that. It's right there. Radius of 8 meters. So this one is on the much, much, much easier side because, yeah, we're given the radius clearly as 8. So we can just plug in that 8 immediately and we're good. A equals pi times 8 squared. 8 squared, remember that's the same as 8 times 8, and that's 64. So because of that, we can replace 8 squared with 64. So we have pi times 64, or 64 pi. And there we are. Final answer is going to be 64 pi, answer choice C. So with that said, everybody, the formulas, they're very clear. It says, and let's go ahead and go through it one more time, especially for those of us that were feeling a little overwhelmed. The formula says pi times r squared. R stands for radius. And what you want to ask yourself is, am I given the radius or am I given something else? Everybody, because it was clearly stated that the radius is 8, booyah, we're good. Now, let's go ahead and remind ourselves that there's a difference between the circumference and the area formulas. For circumference, just remember, let me just go ahead and write it here. Your circumference formulas are these: 2 pi r or pi times d. For the area, we have area equals pi r squared. So feel free to have those written down for yourself so that way we can keep practicing the right way. Remember, the formulas, knowing the formulas makes a huge difference, but memorizing the formulas isn't the only thing. It's not the only thing you should do. It's understanding the pieces of the formulas so you know what to plug in. So with that, let's go ahead and keep it going here. Let's move on to the next one and keep having ourselves a good time. All right, here's the next problem, everybody. As always, read the question first. So it says over here, using this measurement, what is the area of the pond? Okay, so again, I'm only going to highlight the most important things. What is the area? And we're describing the pond. So the moment I see the word area, I want to confirm with myself what shape I'm dealing with, because when I can confirm the shape, I can confirm the formula. So here we are. A circular pond is what I see. Let me go ahead and bring it back over here. So a circular pond is designed such that the distance from its center to any point along the edge is 6 meters. I don't know what all that means yet, but I see that it says the area of a circle, so I will write that formula out. Area equals, and I'm going to look at my notes, pi multiplied by the radius squared. So as always, everybody, what does that R stand for? I just said it. R stands for the radius, correct. So what this means, my party people, what that means is, hey, look, my goal is to find the area, so I gotta fill in this formula. And when I check this out, I gotta find out what R is. If I have R in here, great. If I don't, I gotta figure out what R is. I gotta figure out what the radius is. So when I take a look here, it says the circular pond is designed such that the distance from its center to any point on the edge, it's 6 meters. Let me just draw that out. Okay, we have our circle, and it says such that the distance from its center to any point on the edge. Okay, so let me go ahead and start from the center, and let me go to any point on the edge. Everybody, what am I describing here? What am I showing here? Use your eyes. What is that? From the middle to the edge, not all the way across, from the center to the edge, that's radius. Absolutely. Halfway from the center to the edge, that is radius. That is radius, and that is 6 meters. Remember, everybody, area formula for the area formula for a circle must use the radius. Everybody, which formula is it that can take either the radius or diameter? Which formula is it? Yeah, the formula that goes and uses either radius or diameter, that is going to be, circumference. Circumference, there are two formulas. One is with radius, one is with diameter. The area formula for a circle only uses the radius. And luckily, that's what we're given here. From the center to any point on the edge, that is the radius. Everybody, yes or no, can we confirm that we have the radius, we can plug it in, and we can be done? Perfect. Sounds good. Let's plug it in and keep going. Area equals pi multiplied by, and it says 6 meters. Okay, sounds good. And then we'll square that. 6 squared, which is the same thing as 6 times 6. That is going to be 36. And then we just keep the pi as pi because we look at our answer choices and pi is just pi. Now, pop quiz, everybody. The units here that we see are meters. What is the unit for the area in this problem? Yeah, square meters. Exactly. It's going to be square meters. And there's our answer. Correct answer for this question here is answer choice D. And hopefully we're feeling better and better as time goes on because we're ready for another one. All right, here's our next problem. Let's see what we've got going on. So what we're going to first look at is the question sentence. Determine the distance from the park center to any point along its path. So I think it goes without saying that we're dealing with circles at this current moment in time because we see that it says we're dealing with a circular park. And we want to know the distance from the center to any point along its path. Everybody, what does that scream to you? You know, even if we got confused halfway through this problem, what is it that we are looking for when we describe what we're looking for as the distance from the center to any point along the path? Yeah, that's radius. That is radius all the way. We have got to be able to use these context clues and go from, again, the center to any point along the path. That is radius all day. I'll go ahead and use it right there. We are looking for radius. What is that going to be? Center to any point. So with that said, let's now take in the information. So I'm looking for the radius equals blank. We are going to take the information we have, and it says that the festival organizer designs a circular park where the entire length of the decorative path around the park measures 28 pi units. Quick question, everybody. When we talk about the circular path or the entire length of the path going around the park, what does that scream to you? Remember, there's a difference. There's two things that we could be looking at. One is the space that the entire park takes up, and then there is the distance around the border, the distance around the shape. Which of those are we dealing with? The distance around, and we best associate that with circumference. Remember, area is the space, circumference is the distance around. So we are given this right here, there's 28 pi units. We are given the circumference, and that circumference is 28 pi units. Before we continue, take a moment and ask yourself, answer it if you're here live or out loud if you're watching the recording. Does it make sense to you, even if we don't know how we're going to get it done, does it make sense to you that we have the circumference and we want the radius? Is that clear? Yes or no? Right on. So again, we have the circumference, the entire length of the decorative path going all the way around the park. That's circumference. And we want the distance from the center to any point on the path. We're looking for radius. So everybody, quick question. Is there a formula that relates the radius and the circumference of a circle? And what formula is that going to be? If there is a formula, what is that formula going to be that has the radius and circumference in the same formula? Which formula has the radius and circumference in the same formula? Yeah, that's how you want to think about it. That's how you want to think about it. And so you have radius, you have circumference. Guess what that formula is going to be? Right here, circumference equals 2 times pi times the radius. Not pi r squared. No, 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 no. Pi r squared is the area. 2 pi r, that is circumference. So because we know that, here's what we're going to do next. We're going to keep it calm, cool, and collected. And I'm going to replace the information that I have in the right place. Everybody, which of these letters can we replace? The C or the R? Which can we replace? Yeah, we can replace the C. We can replace the circumference with 28 pi. So with that said, boom, right here. I'm going to replace that with 28 pi. And then everything else, well, the 2 is there, the pi is there, and the radius is there. Everybody, we're looking for the radius. Remember, we talked about this a little bit ago, but let's refresh on that right here. To get the circumference, we multiply 2 times pi times r. But here, we don't have r. We're looking for r. So instead of multiplying everything together, what are we going to do to get the r by itself? Yeah, we're going to divide. We are going to divide. Now, let me take this, we could do this in one step, but I'm going to take 2 steps to do it to give you some ease and confidence. So the first thing I'm going to do is I'm going to divide both sides by 2. If I divide by 2, I see that I can cancel out that 2, nice and easy. Everybody, what's half of 28? 28 divided by 2, that's going to give us, that's going to give us 14. Perfect. So I'm going to move this over, and this is going to be 14 pi equals pi times r. Everybody, we still have something in the way. We still have something in the way because remember, we're trying to get r by itself, but we still have pi right there. Everybody, what operation, if we're currently observing, just looking at this, what is currently happening between the pi and the r? What is currently happening? What operation do we look at and see is happening right now? Yeah, multiplication. Because we don't see an operation, we assume it's multiplication. Remember that solving equations is all about working backwards. So we want to undo or go backwards or the opposite of multiplication, and that's going to be division. We'll divide both sides by pi. Everybody, quick question. Because we have a pi up top and a pi on the bottom, what's that C word that's going to happen? What's that C word? Yeah, it's going to be cancellation. It's going to cancel out. Similarly, if I have a pi up top and a pi on the bottom, what's going to happen here? Oh yeah, that's going to cancel out. What do you know? What do you know? Look at that. My life could be a little bit easier. And there's our answer. We see that we have r equals 14, and that's it. We have found the radius. The radius is 14, and we are good. There's our radius. Booyah, all set. And our answer is A, 14 units. Boom. There we are, everybody. Remember, it is not about memorizing the formula. It's about being able to recognize when you need the formulas and which one you need, in fact. So with that, we still got time. Let's keep it moving here. Let's keep having a good time. And let's get to it. All right, so next one. The question reads, what is the area of the pond? Remember, first thing you want to turn your attention to, hey, what's the question sentence? What are we being asked to find? And it says the area of the pond. Now, in this problem, we're dealing with a circular pond. So the first thing we want to think about is, hey, area, circle, what's that formula? And that formula you're going to write out is the area of a circle is pi multiplied by the radius squared, pi r squared. So what we know we need to solve this problem, because again, we're trying to get to the area. So the one thing I know I'm going to need to get this done is the radius. I need that. If I can get that, then I'm good. So let's read here. Let's see what we have. Don't assume it's the radius, but verify. And if not, then work towards it. So the pond is designed such that the distance from its center to any point along its edge is 18 meters. Okay, so what does that tell me? Man, when we think about the center to any point along its edge, that screams to me, that's radius. We are given the radius because, again, we're going from the center to any point on the edge. That's how I can verify that that's radius and not diameter. So now that I know that, cool. We're going to plug in that 18 and solve, and we're done. And one thing I'll take note of is when you look at your choices, all of them are in terms of pi. So I'm just going to leave pi as is. So here we are. Area equals pi multiplied by the radius, which is 18 squared. So what we really need to do, rather briefly, is multiply 18 by itself. Once we have 18 squared, then we're all good to go. 8 times 8, that's 64, carry the 6. 1 times 8 is 8, carry the 6 is 14. Then we'll move to the next line so we can process that 1. So up next, we're going to have 1 times 8, 1 times 1, add this together. And we're going to have 4, 12, carry the 1, and then 3. No decimals, so no other work to be done. And so there it is. Our area is pi multiplied by 324, or 324 pi. Now, I know for a lot of us here at this point, the anxiety doesn't come from the numbers. I think we all know how to calculate. I think it's more so, hey, can I be certain, can I be sure that what I'm calculating is the right numbers to calculate? You know, and so you really want to think about that, everybody. It's all about that. So with that said, everybody, we are good on this one. Let's go ahead and try one more. All right, let's get to it, everybody. We are taking a look at this problem, and the question reads, what is the distance around the edge of the fountain? So if I didn't know any better, distance around the edge, that's perimeter. But given that we're dealing with a circle, a circular fountain, this is going to be circumference. And so instantly, we want to think about what formula we should use because there are two. The first being circumference equals 2 pi r, where r is the radius. Or we could be using circumference equals pi multiplied by the diameter. Again, d being the diameter. Because we are explicitly given the radius, that takes a lot of the guesswork out. And we can feel pretty good about that. We're given the radius, and so all I got to do is plug in that 37. So that's what I'll do. Circumference equals 2 pi times that 37. And that's going to be our answer. We can leave pi as pi because, well, the answer choices are listed as pi. And so with that, circumference equals 2 times 37. We can fill that out right over here. 37 times 2, that's going to be 7 times 2 is 14. 3 times 2 is 6. Carry the 1. That's 7. So our circumference will be 74 pi meters. That's our answer, and that's going to translate to answer choice B. There we go. That is the solution to this question right there, and I hope that this brings you a little more confidence.